say 60 degrees is going to be about here. And then half of that, and half of those. So these are 15-degree angles here. And so half of 15 is 7.5, right? So I just need to place these evenly. So I have another 60-degree angle over here. Does that seem like perfectly evenly spaced angles? I'm trying. Okay, so if I bisect that, and then bisect these, and bisect those again, we're going to get these points here, right? Okay, then one more time, bisect this, bisect those, bisect these. And so how many dots do I have going around the top here?
A lot.
Many. 1, 2, 3, many. 1, 2, 3, 4, 5, 6, 7, 8 here. So another 8 there, that's 16, another 8 here, that's 24. If I were to go all the way around, I'd have 48, right? So that's what the 7.5 degree arc will buy you, right? If you go 7.5 degree increments of 7.5 degrees around the circle, you're going to get 48 points before you come around to where you started. And we know the degree measure of a right angle is 81 degrees in 2 minutes. Okay, so what happens if we have a 187.5 degree? So that's going to be this, right? So 187.5 degrees, right? Would be that angle there. And what's the chord associated with that angle? Well, do I have a, yeah.
There's that 7.5 or whatever.
It's going to be this length here, right? So if I call this AB, and I say the degree measure of AB is 187.5 degrees. So what is the degree measure of the chord AB? Is there anything in the table that will tell me that?
Could we take 180 away from that to get the degrees from the 7.5 and combine it with 2 of the 90s? Could we do that?
Well, you want to use symmetry here.
So then draw a line straight through from A to its point on the opposite side of the unit circle? Does that?
Yeah, kind of. How about if I were to draw this chord? What can you say about this chord?
It's the same length?
Yeah. Right, so
Okay, just mirror it over.
they're the same length, right? It's going to be the same as A prime B. Right, they have the same length. And is that in my table?
It is.
Yeah. So that would be 172 degrees in 30 minutes, right? 7.5 degrees shy of 180 degrees, and so we already have that in our table, right? So it's just going to, if I were to extend this table to the bottom half of the circle, I would just be repeating these same chord values, right? For arcs beyond 180 degrees. Yeah. So I've got all the information I need already here for the whole circle. Okay. So that kind of answers some of these questions here. Task 6, did we answer these? We measure the central angles that correspond to chords with the size of certain regular polygons. Do these angles appear of arcs in Hipparchus's table? Yeah, they were what? They were 60 degrees and 30 degrees? Yeah, those appeared in the table, right? The inscribed regular polygon in 5C was obtained by halving the arcs between the vertices, right? That was the dodecagon. If this process were repeated once more, how many sides would the resulting inscribed regular polygon have? Well, twice 12, right? 24. Casa Quadragon. I think that's the proper name. The 24, right? How many sides, if you were to do it again? 48, right? We already mentioned that. And how many times could we repeat this? Well, I think one more time and we'd be at 7.5 degrees, right? And then we're at the end of the road. Okay, so let's keep going here. In the column labeled chords in Hipparchus's table, should carry the values of the lengths of the corresponding chords. We will adopt a simple notation referring to the chord, so the chord of, this many degrees. Arc is this many degrees for that chord, right? So notice the chord is always going to be a little bit shorter than the arc, right? So the arc is 37.5 degrees, and the chord is only 36 5/6 degrees. Readers will notice the numbers are roughly equal to those in the first column near the beginning of the table, but they appear as the size of the arc increases. We know that sexagesimal numbers are used to measure angles and arcs, but how are they also being used to measure lengths of line segments? Well, you imagine wrapping the line segment around the arc of the circle, right? So notice that the arc of 7.5 degrees is indistinguishable, right, from the arc. The chord is 7.5 degrees. You see that there's both a chord and an arc drawn in here, and that they're basically indistinguishable, right? That's why 7.5 degree arc measures to the nearest minute 7 and 30 minutes, right? 7 degrees and 30 minutes as a chord. So if you were going to the nearest minute, you would pretty much stop at 7.5, right? Because you can no longer distinguish between them. Okay, so where does that take us then? Task 7. Recall that the formula you learned in school for the relates. Okay, so this is what we've been talking about, right? The conversion from radian to degree. So task 8 in Hipparchus's table, arcs step up in units of 7.5 degrees. Arcs greater than 180 degrees would not need to be considered. Okay, so we've already talked about this one as well, right? That's 187.5. Let's move on to task 9. Oh, we already did that one. Good. Oh. So that was, what is the degree measure of square root of 2?